Hello, in this video, we're going to discuss implicit differentiation. Implicit differentiation. So we'll discuss implicit differentiation by looking at a couple of examples to show you how this works. Examples. Let's start with example 1. In example 1, we have to determine dy dx. So example 1, we have to determine dy dx. For the following. Okay, so we have x squared plus 2x multiplied by sine 4y or sine of 4y is equal to 0. So we are given an equation in two variables, that's x and y, and this is our equation. And we have to use this equation to determine dy dx. So notice that y is a function of x, but we don't know what y is. Y is not explicitly given, so which makes it implicit. Implicit meaning hidden. So that's why this is called implicit differentiation, because we are differentiating a function of x that we don't really know what it looks like. So the function is hidden. So let's go ahead and differentiate. So in order to determine dy dx using this equation, we have to differentiate throughout the equation. So we differentiate the left side of the equation and the right side of the equation. So this implies the following. The derivative with respect to x of the left side of the equation, which is x squared, plus 2x multiplied by sine of 4y is equal to the derivative with respect to x of 0, which implies the following. So now we're going to differentiate the left side of the equation and of course the right side of the equation. The left side gives us the following. So we're going to go ahead and differentiate each of the terms of the left side. So that gives us the derivative of x squared with respect to x plus the derivative of 2x multiplied by sine of 4y with respect to x. This is equal to 0 because the derivative of 0 is equal to 0. So let's continue. The derivative of x squared with respect to x is 2x. So this implies that we have the following, which is 2x plus the following. As you can see over here, the second term on the left side of the equation is the derivative of a product of two functions. We have the derivative of 2x multiplied by the derivative of sine of 4y. So 2x is one function, and sine of 4y is second function. So in this case, we have to apply the chain rule plus the product rule. So we have to apply the product rule first, then the chain rule. because sine of 4y is a composite function. So the first thing we have to do is apply the product rule, because we're differentiating a product of two functions. Then after that, we have to apply the chain rule, because sine of 4y is a composite function. So let's start with the chain rule. Let's start with the product rule, rather. So therefore, we have 2x plus the following. So now we go ahead and we apply our product rule. So we have 2x multiplied by the derivative of sine of 4y. With respect to x. So we have 2x multiplied by the derivative of sine 4y with respect to x, plus sine of 4y multiplied by the derivative of 2x with respect to x. So this is the product rule. This is how we apply the product rule. Is equal to 0, which is the right hand of the equation. It's equal to 0. So let's go ahead and multiply. Let's go ahead and differentiate each of these terms in this product rule on the left side of the equation. So this implies that we have 2x plus, so now we go ahead and we differentiate each of these terms. So the derivative of sine of 4y, we have to evaluate that, we have to calculate that using the chain rule. Okay, so now we have 2x multiplied by the following. So when you're using the chain rule, obviously you're going to let u be equal to 4y, and you're going to go ahead and you're going to apply the chain rule, and you're going to get the following. So it's 2x multiplied by cos of u, which is, you're going to substitute 4y in place of that. So you differentiate the sine function, which is the outer function, and you get cos, and then you're going to substitute 4y in the domain. So you're going to get cos of 4y. Then you differentiate, you multiply this by the derivative of 4y with respect to x. So that's what you get when you apply the chain rule to sine of 4y. You get cos of 4y multiplied by the derivative of 4y with respect to x. So now we add this, and then now we're going to differentiate 2x, which gives us 2. So therefore, in the second term of this product rule, we get 2 multiplied by sine of 4y, close bracket, that's equal to 0. So now we go ahead and we differentiate 4y with respect to x. So we just basically just take out the 4, and we are left with 4 times dy dx. And the 4 is multiplied by this 2 here. So we basically have 4x multiplied by cos of 4y times dy dx. So therefore, on the left-hand side, now we are left with 2x plus 4x multiplied by cos multiplied by dy dx. Okay, let's look at it again. We've got 2x plus 2x multiplied by 4, which is 8x, not 4. So we have a bit of an error here. So let's fix that error. So in place of 4, we'll put 8. This is 8 here. So it's 8x, but 8x multiplied by 4, by cos of 4y, multiplied by dy dx. Okay, so we add this to 2 of sine of 4y. So that's equal to 0. Okay, so now we have to solve for dy dx. That's the aim. We have to solve for dy dx. So in order to do that, we have to subtract from both sides of the equation all the terms that don't contain dy dx, and leave the term that contains dy dx on the left side of the equation. So this is the term that contains dy dx. We leave that on the left side of the equation, and everything else moves to the right. So therefore we get 8x multiplied by cos of 4y multiplied by dy dx. So it's 8x times cos of 4y multiplied by dy dx is equal to minus 2x multiplied. It's minus 2x. Let me write that again. Minus 2 multiplied by sine of 4y. So on the left, we've got 8x times cos of 4y times dy dx is equal to, on the right, we have minus 2x minus 2 sine of 4y, which implies the following. Dy dx on the left, so we solve for dy dx by dividing both sides of this equation by 8x cos of 4y. So dy dx is therefore equal to minus 2x minus 2 multiplied by sine of 4y with respect, divided by 8x multiplied by cos of 4y. So that's the final answer. Let's check this. Dy dx is equal to minus 2x minus 2 multiplied by sine of 4y divided by 8x times cos of 4y. So this is the final answer for this example here. This is the final answer here. That's the final answer here. Okay, so now let's discuss the second example. Let's discuss the second example, example 2. Let's go to the next page. We'll discuss example 2, second example. So in this example here, we are given an equation and we are required to do some calculations. So let's see what we have. For this one, we have to find the gradients of the tangents. Find the gradients. We have to find the gradients of the tangents drawn to the ellipse x squared divided by 4 plus y squared divided by 9 is equal to 2 at the point where x is equal to 2. At the point where x is equal to 2. So that's what we have to do for this particular example. We have to find the gradients. So it's 2 gradients of the tangents drawn to the ellipse given by this equation at the point where x is equal to 2. So note that we have an ellipse in this example. And the point where x is equal to 2 corresponds, of course, to 2 points. When x is 2, you're going to get 2 y values that are on the ellipse. And At those 2 points on the ellipse, you're going to have tangents. And of course, those tangents have gradients. Each of them has a gradient. So they say find the gradients of the tangents drawn to the ellipse at the point where x is equal to 2. That's 2 gradients corresponding to 2 different tangents to the ellipse that is given here. So we're going to go ahead and we're going to calculate what these gradients are using implicit differentiation. So the first thing we do here, we have to differentiate the equation of the ellipse in order to determine dy dx, which of course is the tangent, which is the equation of the tangent of this ellipse, or to this ellipse. So let's go ahead, let's first calculate what dy dx is for this ellipse. Let's go ahead and do that. So we're going to differentiate both sides of the equation. So we say, therefore, the derivative with respect to x of the left side of the equation, which is x squared divided by 4 plus y squared divided by 9. That's the derivative of the left side of the equation. Now that is equal to the derivative with respect to x of the right side of the equation. Okay. Now that implies the following. So the derivative of the left side of the equation, we're obviously going to have to differentiate each of these terms. So this is going to give us 1 over 4 multiplied by the derivative of x squared with respect to x plus 1 over 9 multiplied by the derivative of y squared with respect to x. That is equal to 0 because the derivative of 2 is 0. So therefore you go ahead. Now the derivative of x squared with respect to x is 2x. So now we are left with 2 over 4 multiplied by dx dx. That's what we're left with. So we have 2x. So let's write it down. We have 1 over 4 multiplied by 2x plus 1 over 9 multiplied by the following. So over here, if you look at dy, we have the derivative of y squared with respect to x. So we obviously have to apply the power rule of differentiation. So this is 1 over 9 multiplied by the following. 2 multiplied by y multiplied by the derivative of y with respect to x. So we apply the power rule of differentiation to that. Or you can apply the chain rule. It will still give you the same result. So now we have 1 over 4 times 2x, which gives us x over 2 plus 2 over 9 multiplied by y multiplied by dy dx is equal to 0. So now we have to solve for dy dx. We have to solve for dy dx. So we are going to then have the following. This implies the following. So we leave the term that contains dy dx on the right-hand side of the equation. Sorry, on the left side of the equation. So now we got 2 over 9 times y multiplied by dy dx on the left. And then on the right, we've got minus x over 2 on the right side of the equation. So we subtract both sides by x over 2. And then we have this, we are left with this. So that now we divide both sides by 2 over 9 times y. We divide both sides by 2 over 9 multiplied by 1. And that gives us the following. Okay, let me go continue here. So that implies the following. So we are left with dy dx is equal to the following. minus 9 over 4 multiplied by x over y. Multiplied by x over y. And that's what dy dx is equal to. So dy dx is equal to minus 9 over 4 multiplied by x over y. So that is dy dx for this particular equation. That's what it gives us. So now that we have what dy dx is, which of course is the equation of the tangent to the ellipse at any point xy. This is the equation of the tangent to the ellipse at any point xy. But what we're interested in, as the example stated, we're interested in the gradients of the tangents drawn to the ellipse at the point where x is equal to 2. That's what we're interested in. So now we go and we have to find the corresponding y values for the point where x is equal to 2. We have to find the corresponding y values for the points where x is equal to 2 so that we can then substitute x and y in order to determine dy dx at those points. Okay, so in order to determine the corresponding y value of these 2 points where x is equal to 2, we have to solve this equation that is given to us here, which is the equation of the ellipse. We have to solve this equation, solve it for y, and then substitute x is equal to 2 to find the corresponding y values. So solving this equation gets us the following. So if you solve the given equation of the ellipse, if you solve the given equation of the ellipse and you solve it for y specifically, so you solve for y, the given equation of the ellipse, which of course is x squared over 4 plus y squared over 9 is equal to 2. So you solve for y, this given equation of the ellipse. So you go ahead and you solve, you're going to get the following. You're going to get that y is equal to plus minus the square root of 18 minus 9x squared divided by 4. So that's what you get. Solving this equation of the ellipse, solving it for y, will get you y is equal to plus minus 18 minus 9x squared over 4. It'll get you y is equal to the plus minus the square root of 18 minus 9x squared over 4. Okay, so obviously the plus minus shows you that you've got 2 points, you've got 2 values of y. For any x value, you will have 2 values of y. So therefore, when x is equal to 2, that's going to imply the following. X is equal to implies that y is equal to the square roots of 18 minus 9 multiplied by 2 squared over 4 plus minus. Okay, so x is equal to 2 implies that y is plus minus this. It's plus minus this. So that basically implies the following. It implies that y is equal to 3. So you just basically just go and just work this out in your calculator. You get that y is equal to 3, or y is equal to minus 3. So you get 2 y values that correspond to x is equal to 2. So therefore, that's basically 2 points. That's 2 points. Okay, and the 2 points is obviously the point 2 minus 3 and the point 2, 3. Okay, so then the corresponding gradients that correspond to these 2 points, you get them by simply just substituting these 2 points in dy dx is equal to minus 9 over 4 multiplied by x over y. You substitute each point here to get the corresponding gradients at these points. Okay, so substituting then these points gets you the following. So therefore, at the point 2, 3, dy dx is given by dy dx is equal to minus 3 minus 9 rather over 4 multiplied by 2 over 3. Okay, and that is equal to minus 3 over 2. So that's the answer for that. And at the point 2 minus 3, dy dx is equal to minus 9 over 4 multiplied by 2 over minus 3, which is equal to 3 over 2. So these are the 2 different gradients that correspond to x is equal to 2. So we've then calculated what we were asked to calculate. So that's all we had to do in this video. So this is the end of the video. If you like the video, subscribe to the channel and hit the like button. Thank you.